Hi everyone, welcome to Chemicos Academy. So we were discussing photochemical reactions. We discussed Norwich type 1, 2 and Pectinobucci reactions in our previous video. So in this video we will see what is dipyrmethane rearrangement. This is an important rearrangement reaction in photochemistry. So let's see what is dipyrmethane. So photolysis of 1,4-diene is called dipyrmethane rearrangement. 1,4-diene. In first and fourth position a double bond will be present. This is 1,4-diene. 1, 2, 3, 4 and 5. So this is a 1,4-diene and photolysis of this 1,4-diene is called dipyrmethane rearrangement. And another important point was 1,5-biradical is the intermediate in this reaction. And we have seen in Pectinobucci reaction 1,4-biradical. So in dipyrmethane rearrangement 1,5-biradical is the intermediate. And 1,4-diene in presence of sunlight is converted to a cyclopropane with double bond. So this is the compound we are getting when the photolysis 1,4-diene in presence of sunlight. That is the product. So we will see the mechanism, then you will understand better. And another important point was how to identify the double bond or 1,4-diene compound in dipyrmethane rearrangement. So we will identify the particular 1,4-diene by looking into the third carbon or in between the carbon in between double bond. That is the third carbon, which should be saturated carbon. So third carbon must be saturated carbon or sp3 hybridized carbon. Then we can take that compound as 1,4-diene for dipyrmethane rearrangement. So this point will be important for solving problems. And another important point is 1,5-biradical intermediate. And like in Pectinobucci, the stability of 1,5-biradical intermediate determines the product in dipyrmethane rearrangement also. So let's see the mechanism. Now let's do the mechanism. So first we are taking a 1,4-diene. 1,4-diene. 1, 2, 3, 4, 5. And in third position a saturated carbon is present, sp3 hybridized carbon. And we are doing photolysis. So like all photochemical reactions, the homolytic cleavage of this bond occurs. So we will get a radical. 1, 2, 3, 4. And 4 radicals are formed. Now what happens? This will combine to form a cyclopropane ring. So this is forming as a cyclopropane ring, and here a radical comes. And in next step we have to do another homolytic cleavage. And we can't break this newly formed bond. So we will break from this side or this side, A or B. In this case both sides are same. So no problem. We can cleave any of the side. Let's cleave A. We are cleaving from this side, not this side. So what will be the structure formed? Here a radical comes. Here already a radical present. Then here a radical, this is B, and B will be same. Now what happens? Here a radical is present. Now what happens? This can make a bond. So a double bond is formed. This will make a bond, and here a radical and here a radical. Okay. Now what happens? These can make a bond. So 1, 2 and newly formed bond 3. 1, 2, 3. A cyclopropane ring is formed. So we will write this as a cyclopropane ring. How? This bond 1, 2 and 3. 1, 2 and 3. So a cyclopropane ring is formed here. So this is dipyrmethane rearrangement. From a 1,4-diene, a cyclopropane ring with a double bond is formed. How we do the dipyrmethane rearrangement? First, homolytically cleave the double bonds. Radicals are formed. Then make a cyclopropane ring. Then by considering the stability of 1,5 radical. This is 1,5 radical. So we have to consider the 1,5 radical stability. Here there is no issue in stability because both sides are same. Like in Pattano-Gucci reaction, we will do the cleavage by looking into stability of 1,5 radical. Then we will write the product as cyclopropane ring with a double bond. And let's do the examples one by one. So in first example, this is a 1,4 diene. So 1, 2, 3, 4, 5. In third carbon, sp3 carbon is present. So what will be the rearrangement? Here methyl group, here also methyl group and 2 pH. pH, pH. Now we are going to cleave these two bonds. Homolytic cleavage. So two radicals are formed. Now we will join this. Okay. Now cyclopropane ring is formed. Now next step is cleavage. Cleavage from this side or this side. A or B. So first we can cleave from A. So we are cleaving from A. So what will be the structure? Here a radical comes and here a radical comes here. And the rest is same. Here pH, pH and a radical. Here also a radical is present. Now just look on the stability. Now what happens? Here we cleaved and then formed double bond. So here also we are forming double bond. pH, pH. And here a double bond formed and here a radical is there and here also a radical. Now we have to form the cyclopropane ring. So this will make a cyclopropane ring. So the product is pH, pH and this is making a cyclopropane ring. So we can write this as a double bond, then a cyclopropane ring with 2 pH. Okay. Sorry, here pH and here methyl group is present. Methyl group. So this is the compound which formed when we are cleaving from A side, this side. Now we are cleaving from B side, this side. So what will be the product? Here a radical, then this A is same. Now we are cleaving from this side, no? So here 2 methyl group comes and here a radical comes and here 2 pH. Here also a radical is present. Now we are cleaving from B side. Now what is the next step? A double bond is formed. So here a double bond will form, 2 pH and here 2 methyl group, a radical. Here also 2 methyl groups are present. Now here a radical is formed. Here a radical is there. Now in next step we have to form a cyclopropane ring. After writing the products, we will check the stability of the radicals. So first you have to write the product. pH, pH, 2 methyl group, sorry, here a double bond and here we are forming cyclopropane ring. This can be written like this. A cyclopropane ring with 2 methyl groups. So this is the product we are getting from cleaving B side. Now we have to check the stability of 1,5 biradical. 1,5 biradical in cleaving A is this. So here the radical is in phenylic position. Benzylic radical is present. So benzylic radical is more stable than other radicals. So this will be stable. By looking on to B cleavage, the 1,5 biradical here is connected to, this is a tertiary radical. Benzylic or phenylic radical is more stable than tertiary. So A is more stable. So the major product will be this one. This will be the major product. And this will be minor product. So you have to look on the stability of 1,5 biradical and determine the product, which will be the major and minor product. So first you have to cleave homolytic cleavage, do homolytic cleavage, then another cleavage will be done based on the stability of 1,5 biradical formed, and write the product according to the stability of radical formed. Go to second example. Here two double bonds are given, and let's check whether 1,4-diene is present. 1, 2, 3, 4. So 1,4-diene is not present. This is 1,3-diene. So we have to open this phenyl ring. Two phenyl rings are given. So just open any of the pH. So I am opening this phenyl ring. And here two double bonds. Now check the 1,4-diene. This is not 1,4-diene, so we will number from here. 1, 2, 3, 4, 5. Yes, 1,4-diene is present. Now we have to do the homolytic cleavage. So this is homolytically cleaved and this is cleaved. So we will get a cyclohexane with one double bond and two radicals here and a pH, and this is also homolytically cleaved. So here a radical comes, here a radical comes, and these bonds are same. Now we have to make a cyclopropane ring. From connecting this we can make a cyclopropane ring. 1, 2, 3. So we are making a cyclopropane ring. Here double bonds, here radical, and here a pH, here another phenyl ring, two double bonds, a radical, and this radical makes a cyclopropane ring. And now what happens? Another homolytic cleavage should be taken place, and this is newly formed bond, so this is not break. So either this or this can be break. This is not break, because if we break this cyclohexane ring will be lost and there will be no aromaticity in this phenyl ring. So we will break this bond, this A, and this is B. We will break A bond. So we will get here a radical and here a pH. Then okay, we are breaking this A bond. So here comes a radical, and here what happens? This bond. So this radical and this radical, here a radical comes when A bond is break. This radical and this radical makes a bond. So aromaticity is maintained. So we will prefer A cleavage because we have to maintain the aromaticity. So here aromaticity is maintained. Here a bond radical comes. Here a radical is present and here also a radical is present. So what will be the product? This will make a bond. Another cyclopropane ring is formed. So this is the product from this 1,5,1,4-diene. Third example, we have to identify the 1,4-diene. So this is a benzene ring and this will be the 1,4-diene. 1, 2, 3, 4, 5. And third carbon should be saturated carbon. And here it is sp3 hybridized. So it's a saturated carbon. So now what happens? Homolytic cleavage of these two bonds. So homolytically it is cleaved. So radical is formed. Here two radicals formed. Now next step is to form cyclopropane ring. So this can be made into a cyclopropane ring. So this is made into cyclopropane ring. Now next step is another homolytic cleavage. Here 2 pH Another homolytic cleavage is done. So from which side homolytic cleavage can take place? From this side or this side, A or B. If we cleave from this side, we will get a radical at this position. And if we cleave from B side, we will get a radical on this position. So here there is no radical. So if we cleave from A, we will get a radical in this position, and these two radicals can combine into a bond, and the aromaticity of this phenyl ring is maintained. But if we cleave from B side, the radical is present here, the aromaticity of phenyl ring is lost. So we will prefer aromaticity. So we will cleave from A side. So what will be the product? We are cleaving from A side. So here a radical is present, here a bond, and here also a radical. Then here the remaining B side, PH, PH, and a radical. Now these will form a bond. Aromaticity is maintained. So aromaticity is maintained. And okay, here also a radical is formed. Now cyclopropane ring is formed by combining these two radicals, 1, 2 and 3. Cyclopropane ring is formed. So we can form a cyclopropane ring. Now pH, 2 pH is present in cyclopropane ring. So this is the product we are getting from third example. So first you have to identify the 1,4-diene, then homolytically cleave, then do another cleavage by looking into stability of 1,5 radical. And fourth example, first you have to identify the 1,4-diene. So this is not 1,4-diene and this is 1,4-diene. 1, 2, 3, 4, 5. This is a 1,4-diene with third carbon saturated carbon. So we will do the homolytic cleavage of this side, this and this. So we will get a radical and the rest is same. And next step is make a cyclopropane ring. So we will make a cyclopropane ring like this. And two radicals are left. Now what is the next step? Another homolytic cleavage. So another homolytic cleavage is done from this side or this side, A or B. Now you have to do both cleavage and find out which is stable. Now we are doing the A cleavage. First, A cleavage. So this A is cleaved. So what will be the product? Here a radical comes, here a radical comes, and here B side a radical comes and double bond. Here already two radicals are present. Now next step is making this double bond. So this is formed as double bond. Now again we have to make the cyclopropane ring. So we are making the cyclopropane ring. Here two medial group and here this will make a cyclopropane ring and double bond. Okay, here also a double bond is present. So this is the product A. Now we are doing B cleavage, B, from this side. So we will get here two radicals. So B is cleaving, so this will have a radical and here also a radical, then double bond. Now what is the next step? We will make these two connect and make a double bond. Now again we have to make a cyclopropane ring by combining these. So I will write like this. We will make a cyclopropane ring and two medial group, 1, 2, 3. And then here a double bond, here a double bond. Now this is the product B. Now you have to look on the stability of these two products. Here conjugation is possible. Here there is no conjugation. So we will prefer conjugation. So this B product will be the major product. So from cleavage of B is preferred in this example. So you have to look on the stability of the products. The conjugation is present. So we will cleave the bond B. Do this fifth example. So here we have to identify the 1,4-diene. So this is a benzene ring and a double bond. So this can be taken as 1,4-diene, and this carbon is a saturated carbon also. So let's do dipymidine rearrangement. So here this bond is homolytically cleaved and this bond is homolytically cleaved. So here comes the radical and here also a radical present. Then here a radical and a pH. Now next step is cyclopropane formation. So this can be made as a cyclopropane ring. So a cyclopropane is formed. Here a radical pH, here a radical, and these bonds are not affected. Okay. Now what is the next step? Another homolytic cleavage. So we can't cleave this newly bond form. So we will cleave from this side or this side, A or B. Now we know we have to maintain the aromaticity. So we know we will cleave from this side only, so that we will get a radical in this side. If we cleave from B side, we will get a radical in this side. That's not useful for us. So we will cleave from A to maintain aromaticity. So the double bond regenerated. Here comes a radical and this will make a double bond. So this is the rest compound. Here pH and a radical, and here we are cleaving no. So this is not affected. This is not affected. So here comes another radical. Here we are not cleaving, so here a radical comes and here a radical comes. So that is represented here. Now next step is to again form a cyclopropane ring. So 1, 1, 2 and 3. A cyclopropane ring is formed. And this is benzene and a cyclopropane is formed. 1, 2, 3. 2, 3. And a pH. So this is the product we are getting. So these were the points regarding dipymidine rearrangement. So what is dipymidine rearrangement? It is the photolysis of 1,4-diene. In 1,4-diene, the third carbon should be saturated carbon or sp3 hybridized. That's the main point. And another important point is the stability of 1,5-radical biradical intermediate formed. In Paterno-Gucci reaction, we saw the 1,4 biradical, but here 1,5 biradical is the intermediate formed in dipymidine rearrangement. And we have solved some problems and we have seen the mechanism also. So I hope you all understand, and we will see another reaction in next video.